Hello, today we are going to talk about proteins again, but we're gonna focus on their structures, okay? So my mic works, let's go. So what's so special about proteins? Well, they are essential biomolecules that play a central role in, the cellular function. And they make up about 15%. Wait, where is my... Does this work? Yes. 15% of the cell mass. Let's make this a bit thicker. There you go. Okay. Yeah, 15% of a cell's mass and the ultimate products of most genes. They are also the most diverse of all biomolecules. And yes, just most diverse and they can adopt like a wide variety of structures. Most common types of enzymes and reactions they catalyze, those are proteins, and there are some different types. For example, let me just write it out here. I have to erase it. No, my eraser should be bigger. There you go. Okay, good. So let's start with the different enzymes. We have hydrolase. Those are enzymes that catalyze hydrolytic cleavage reactions. Whoa, what's happening to the size of this? Wait. There. Okay. Let's write that again. Erase. Okay, so hydrolases. Those are for cleavage reactions. You have nucleases and proteases. There are more specific names for those. Nucleases would... Can't say, wait, let me just read this. Yeah, nucleases would break down amino acids. Meanwhile, proteases break them down by hydrolyzing the bonds. Synthases synthesize the molecules. Ligases join, like ligate them. Isomerases catalyze the rearrangement of the bonds. Kinases add the phosphate groups. Okay, don't forget this. Kinases and phosphatases. Okay, kinases add phosphate groups. Phosphatases remove the phosphate group. Remove the P. Okay? Kinases add, phosphatases remove them. So, and then you have the ATPases, hydrolyze ATP, and GTPases, which make GTP. And then for the amino acid, we have... Let's erase this. What's the structure of an amino acid? We know that you have a central carbon. You have the H. You have the COOH carboxyl, and then you have the amino group plus the what? The side chain. This is where all the action happens. The rest, that's the skeleton. So again, what's the structure of an amino acid, which is the building blocks of protein? You have an alpha carbon H, COOH carboxyl, and then you have the amino group. So R is commonly around 20 side chains. It depends. And then at pH 7, both the amino and carboxyl groups are ionized. So at pH 7, both the amino group and carboxyl group are ions. So the ion form of the carboxyl group is COO minus. All right. Good. And then you have a thing called optical isomers, where amino acids can exist as like a mirror of the other one. So how does that look like? Well, let's draw it out. Let's draw it here. How it looks like is this. You have the alpha carbon, right? then COO minus, and NH3 plus. You have the H, you have the R, and then we have a mirror plane. Just flip it. So now you have COO minus here, the alpha carbon H, and then the NH3 plus, and the R. See, it's a mirror. Just flip it. That's optical isomers, and the stereochemistry is crucial for the proper function and folding. Now, for families of amino acids, they are grouped according to their side chains. You have acidic and basic, uncharged and non-polar. So for acidic, those can donate protons. Basic will accept protons. How does that look like? Okay, so for acidic, they have the H, they can give the H. Bases take the H. So acidic, give. Away, donate, A. Okay. And then remember that the 20 amino acids have have both 3-letter and 1-letter abbreviations. Alright? Right now, oh no. These have just looking at the structures again. Okay, fine. Let's calm down. Let's remember the non-polar. Let's start slow. The non-polar amino acids are, it's the family, what was it? We have a mini term for it. Family VW. Alright. Alright, okay. Erase. Non-polar. Non-polar is family VW. It is, where is it? Phenylalanine. Yeah, phenylalanine, alanine, methionine, isoleucine, leucine. What's the Y? Tryptophan? But that's uncharged polar. VW is valine, and then tryptophan. Oh, tyrosine is the Y. It's kind of weird. Tyrosine is a bit weird because it's uncharged polar but also can be non-polar. So just remember that one. Aspartic acid. How can we... Wait, let's think about this. There should be a way to remember then. We know that the positive amino acids are the RKH, arginine, lysine, histidine. Negatives are aspartic acid and glutamine, DE. Okay. And then if we want to draw them, let's start with glycine. Okay. Here. Glycine. Amino acid side chains. Okay, glycine looks like this. No. Let's just flip it around. Alpha carbon, HCOO minus, and H3. Glycine is the simplest one, just the H. Alanine has the CH3, but valine has CH3. Okay, slowly but surely. Glycine, alanine, valine. Oh, I said Gav limp FW before. No, we remember that one. So glycine, C, H, and H. No. NH3. Whoops, my marker. NH3, COOH. This is a plus, COO minus, erase the H. Glycine is just H, alanine, CH3, valine, CH3, CH3. Okay, cool. Now you have leucine. 1, 2, 3. Isoleucine is an iteration. If we just want to write their thing again, glycine. Yeah, glycine. CH3 is alanine. CH3. Oops. No. This one. CH3. CH3. No, go to the carbon, please. Thank you. CH3. That's valine. And then what was it? Leucine. Limp. Leucine is just a longer version. CH3. CH3. No. Like this. We have to draw the lines clearly. Okay, CH3, CH3. Yes, glycine, alanine, valine, isoleucine. Or leucine, that's leucine. Gaval. And then isoleucine is... Okay, you have a C. CH3, CH2, and CH3. Just a straight version of leucine. GA. Hello, great teacher, welcome back. We are now trying to draw the amino acid side chains. Yes, this is okay, a normal amino acid, right? We know it. It's like the alpha carbon, hydrogen, COO, that's the carboxyl, and H3N plus, right? And then we are now trying to draw out the different R's. So far we have 5. We have glycine, that's just H. Alanine, valine with the CH3, CH3. Leucine being just a more complicated version of valine. And then isoleucine, the straight version of leucine. Alright, so far we have 5 out of 20. Great progress. Now let's continue with the next 5. Why did it pop up? Let me just refresh it. Hopefully it will appear. Yes, now it's appearing. Hooray. Okay, there you go. So now let's go with methionine. So methionine, normally we have this again, right? COO minus, hydrogen, H3N plus. Methionine is CH2, CH2, sulfur, CH3. So that's methionine, CH2, CH2, sulfur, CH3. All of these are nonpolar. And then you have proline. Proline is weird. It's very cyclic. So let's I'm gonna try to be patient with it. COO minus, H3N plus. Now let's start here, and then it's like it forms a 5-member ring or something. Wait, where is it connecting? Slowly but surely we can do it. Okay, so this carbon is connected to a CH2, CH2 again, CH2 again, and U. CH2, how many CH2s? 1, 2, 3. Let's write it. Let's label 1, 2, 3, 4, 5. See, that's why it's weird. It is weird. Did I write that properly? 1, 2, 3, 4, 5. Yeah, now it looks like a pentagon. Okay, that's great. So again, C and H, COO minus, H and H3N plus, and then 3 of these, and then bam, go there. 2, 3, 4, 5. Good. See, pentagon. So that's why it's weird. Oh, this is just H2 too, because we don't want too much on it. That's proline. Okay, now calm down. There's another thing that's weird. Phenylalanine. Phenylalanine, HCCOO minus, H3N plus. Phenylalanine is CH2, and then a benzene ring. Okay, looks better than proline. Proline is this, and then this is phenylalanine. Let's try to draw them all again. And before I add another one. Okay, let's start with... Oh, wait. Where's my pencil? I have to note down how it's gonna be. Later, I wanna try and draw the structure of the ATP and all 20 amino acids. There. Okay, so start glycine. If we want glycine, this is COO minus, H3N plus. Glycine is just H. And then alanine is CH3. Valine is CH3. It's the letter V, CH3. Isoleucine, CH3. And then I think that's a CH2. Oh no, this is a C. This is a CH3, a C, and then 2 more C's. CH2, CH3. Yes. Yeah. So G, glycine, alanine, valine, isoleucine. Wait, what? 1, 2, 3, 4. Glycine, alanine, valine, isoleucine. I missed out on normal leucine. Normal leucine looks like CH3. I forgot it. Sorry. Just a CH2. Oh, CH2, CH2 before it branches out. There's an extra one. CH2 and then... Oh, no. Too much. CH2 and then CH before it, branches out. CH2, CH. 1, 2, 3, 4, 5. Next. GAVLI. Oh, methionine. Methionine is, let's start here. H, CO minus, H3N plus, CH2, S, sulfur, CH3. That's methionine. Gav, limp. Phenylalanine is, you have a CH2 and then benzene ring. Oh, I forgot. Proline, the one that I did not want. Fine, I will try. Proline is CCO minus, H2 and plus H. Connect 1, 2, 3. Bam. Good job. That's proline. Gav, limp, F, phenylalanine, W, tryptophan. We did not draw it earlier. Now we will. C, H, CO minus, H3 and plus, and then CH2. Okay, now let's calm down. This one's gonna be weird, but you go down. That's a bond, and then let's try to make a benzene ring here. But here, you have one here. Go like that and like this. The piatos bond N H. That's tryptophan. Trip W. Okay, terpy W. Okay, so far we have the non-polar ones. Let's try and draw them one more time and then write the... No. Let's write their first names. Their mini names. So far we have the non-polar ones. Gav, limp, FW. Glycine. This is just G. Alanine, Ala, A. Valine, Val, V. Leucine, Lu, L. Nice. Isoleucine, Ile, I. Methionine, Met, M. Proline, Pro, and a P. F. Phenylalanine, with a what is a PHE with an F, and then tryptophan with a TRP but symbol W. Good. How many is that? 1, 2, 3. Wait, G, 3, 4, 5, 6, 7, 8, 9. Wonderful. 9 out of 20. So we have the non-polar. Commit that to memory. And now we move on to the next ones. Next is uncharged polar. So now we're moving to the polar, polar, uncharged, and charged. Let's see. This is gonna be stun QYC. Stun QYC. Why is it like that? They're partners. Okay, fine. We have Serine, Sir, S. Threonine, Thur, T. Asparagine, Asin, N. Glutamine. This is uncharged polar, okay? Glutamine, glun. This is glun. Q. Tyrosine, tyre, Y. Tyrosine, tyre, Y. Cysteine, C. Good. Okay. And now let's try that again, slowly but surely, and then mix it later with our non-polar. So for serine, we have C, H, COO minus, H3N plus. Serine is CH2OH. See? Uncharged polar. With the oxygen, it's here. Serine. And then you have threonine. CH, COO minus, H3N plus. Threonine looks like this. C, another OH, but you have a CH3. And then this is just an extra charge, if ever. That's threonine. 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 Okay? So again, let's mix it with, let's go from the top. Our non-polar amino acids were glycine, gly with a G. Glycine is C, H, COO minus, and NH3 plus. Glycine is just H. Alanine, Ala, A, it is CH3. Valine, Val, V, If you try and write it out, CHCOO minus H3N plus. Valine is CH also, and a CH. That's valine. It's a letter V. CH3, CH3. This is just an H, yeah, because it has 4 already. G, Gav. Next, continuing the non-polar. You have limp leucine, Lu, L. This is just a straight valine, so CHCOO minus H3N plus C, and a C. So you have a CH here, CH2, CH3, CH3. Nice. It's leucine. Wait, that's isoleucine. Yeah, that's the straight one. That's isoleucine. Why? I keep on skipping normal leucine. That's I. Normal leucine is just a longer valine. Let's write it again. If we start with valine, okay, I'll write it properly. HCCOO minus H3N plus valine, C, okay? H3, CH3. That's valine, val, V. And then leucine, focus. Leucine is Lu and L. If you have HCCOO minus H3N plus CH, and then you split. Nice. CH2, CH3, CH3. And then isoleucine, I, CHCOO minus H3N plus. And then a straight leucine is an isoleucine, so you go C, CH3, H2, H3, isoleucine. Okay. G, who is the next one? G, M. Oh, it's the methionine, proline, phenylalanine, tryptophan. Gavli. Can I make the marker a tad bit, thinner? Yes, we can. Okay, now we are at Gavlim FW. Who are these? This is methionine, met. How it looks like is this: HCCOO minus H3N plus. Methionine is CH. It's a CCSC H2 CH3. Proline is weird. It looks like a ring. O minus H2 and plus 1, 2, 3, 4. Great. And then you have phenylalanine, alanine. You have Fe and F. COO minus H3N plus. How did phenylalanine look like? The one with the benzene ring. Okay. So phenylalanine is CH2 benzene. And then tryptophan is the other weird one. Tryptophan. Trip, TR. This is terp. C, HCOO minus, H3N plus. This one is like, there's a C here, and then you have a house and a benzene ring. This is the bond here, H2, and then an NH. Yet, okay, nice. Clap, clap, clap. So we have the non-polar now. Moving to the polar uncharged. Gav, limp, FW. Oh, it was stun Q something. We did Sarin before. Sarin Sir S. This one is CH COO minus and H3 plus. Okay, how did it look like? I think it has a CH2 and an OH. Yes, Sarin is CH2OH. Now N As this is asparagine. No, threonine. Threonine. Threonine is, I don't remember. Oh, another OH, but has an extra CH. Okay, go straight. CH2 OH. Oh, this is just H because it has an extra CH. 3. This is threonine. C exclamation. So again, let's try. Hello, Mr. Big Boss. Welcome back to the stream. Hi, Landor. Welcome back to the stream as well. Currently trying to draw the 20 amino acids. So far we did the 9 non-polar, and then we have the polar now. What's that called? The polar uncharged. So I was trying to draw the difference between serine and threonine, because this one is tripping me up. Serine is Sir S. We have C, a normal amino acid is this, C and then hydrogen, and then COO minus, H3N plus, and then serine is, this one is CH something, and then OH. Perfect. Okay, and then threonine is Thr and a T, CHCOO minus, H3N plus, and then threonine. Where is what's the bottom part? No, it's fine. Oh, the C asterisk OH CH3. Nice. Okay, calm down. We got it. Remember that. And then we're gonna add a couple more. Because for the non-polar, for the uncharged polar, it has ST NG stun Q. Oh, the stun Q YC kind of looks like. How do we remember this? Wait a second, I just need to drink water. Okay. Okay, now we're back. So how can we remember this STNQYC? Serine, threonine, asparagine, glutamine, tyrosine, cysteine. Stun QYC. Stunk? No, just stun QYC. We drew serine and threonine, that's fine. Let's focus here. Asparagine, ASN, Asparagine is... Okay, calm down. We can do this. Breathe. CH2, COO minus, H3N plus. Now, for its side chains. Asparagine, CH2, C double bond O, and N, H2. Okay. So it's CH2, C double bond O, and I've seen this one so many times, but it has to stick. Okay. CHCO minus H3N plus CH2. Asparagine. And then its friend, glutamine. I don't know why it's Q. Glutamine. Glun. Symbol is Q. Oh, it's up there. COO minus H3N plus H. Now it's just a longer form, right? CH2, and a C double bond O, H2N. Yet, okay. So let's slowly but surely build it. Stun Q. Let's add the YC later. We did serine, Sir, S. How does it look like? CHCOO minus H3N plus. This one, calm down. CH2OH. Okay, serine, CH2OH. Threonine next. Threonine is CHCOO minus H3N plus no, like that. It's an asterisk C, and then it has an OH, but you have a CH2 there. Threonine. Good job. Okay. Next, STNQ. Asparagine. Yes, asparagine. N. Asin. That's asparagine, right? I was gonna say asparagus. Asparagine. CHCOO minus H3N plus. Asparagine is, we have a CH2, a C something, C double bond O, H3, an O2, H2N. Is that right? Yes. Asparagine. Glutamine. And this is Q. Glun. CHCOO minus H3N plus CH2, another C before you expand CH2, and then the C. H2N. Beautiful. Alright. So now that we have the stun, what was it? ST and stun Q, YC. Stun Q, YC. Now this is tyrosine, YC, and cysteine. Tyrosine, tyre, cysteine, and cis. Alright, calm down. It's alright. It's gonna be okay. Tyrosine. This one is CHCOO minus H3N plus. Has a weird thing. You have a CH2, you have a benzene ring. It looks like something we wrote before. Who was this? Phenylalanine. But if you add an OH, that's now tyrosine. Oh my gosh. Okay. We have to know that. Okay. I imagine it would be fun if there's like cards. Like, what's that called? The flashcards that pop up. A mini quiz. Yes, so again, let's try it. Stun Q, YC. Y. Tyrosine. Tyrosine. So this is gonna be Okay, start with the alpha carbon. CH, COO minus, H3N plus, CH2, yes, yes. We first write the phenylalanine, but add an OH, boom, tyrosine. And then stand YC, cysteine, cis, and the C. See, this one is a bit simpler. Hopefully. Yeah, CH3N plus, tyrosine is to CH2SH. Yay! CH2SH. Yes, yes, good. Okay, now let's start from the non-polar again. Because so far we have 9 plus ST and QIC plus 6, I think, so now 15. Non-polar would be glycine, G, alanine, A, valine, V, leucine, L, isoleucine, I, methionine, M, proline, that's the circle one, P, limp. Okay, finish that one. And then you have polar uncharged. Who is it? Serine, serine S, threonine, asparagine, N, glutamine, G, no, yes, no, Q, yes, and YC, tyrosine, what is this spelling? Tyrosine, Y, tyre and Y. And who's the last one? Cysteine. S, C. Yeah, C. S is serine. Oh my gosh. Okay, now we wrote their names. Let's try to draw them again. Just to make sure that they stick. Okay. Glycine. No, it's okay. Is it glycine? Just CO minus. H3N plus glycine H. Good. If someone says, can you draw the structure of alanine? Okay. Just its R is CH3. Okay, great. And then if they ask for valine, then we cook up this structure. H3N plus valine, that one is C, and then C and a C. That one is CH3. And if the senseis ask for leucine, just make it into a longer valine, which is this one, COO minus, H3N plus, C and a C. That's a leucine. And if I ask, what about an isoleucine? Oh, it's just a straight leucine. H3N plus, COO minus, C here, C and a C and a C. Great. Isoleucine, and someone asks for, what about a methionine? Oh, methionine, it's this one, COO minus, H3N plus, CSC. Methionine. How about pyrroline? That one looks like a ring. proline is here. Let's draw it properly. CO minus H2 and plus 1, 2, 3, 4. Bam! Cue the dab. Okay, perfect. Oh, I thought I was erasing. Next, proline, gav, limp, FW, phenylalanine. Oh no. Oh, it's okay. It's okay. It's okay. It's okay. Chill out. Chill. 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 CO minus H3 and plus phenylalanine. That's the one that looks like this. Yes. Beautiful. Now you have W, tryptophan, C, HCOO minus, H3N plus. Tryptophan is like this. You have a C, and you write a house. Then you write a benzene ring at the bottom of the house. You have an N, H, and a bond. This is H2. Good. Good. So we did the non-polar so far. Now let's draw the polar uncharged. What is serine? Okay. Yes, sensei. Serine is... Oh my gosh, it's like Ruby-chan. Hi. Okay, no. Don't do that. Calm down. It's okay. COO minus H3 and plus serine. Focus on the serine. C... H2. I think this is OH. Oh, hello. It's okay. Just drink water and biogesic. Thank you for dropping by in the stream. This is serine, right? Yes, CH2OH. This is serine. And then threonine. Threonine. Oh, by the way, you can change your hat if you type exclamation hat. That's for the mini character on the screen. Okay, you have CH. How does threonine look like? COO minus H3N plus threonine. Oh no. No, it's okay. Threonine is like this, right? It has an OH and then has a CH3. Right? Right? Okay, good. Threonine. It's serine, threonine, asparagine, and Q next. Q, not O. Asparagine. Asparagine looks like this. H, CO minus, H3 and plus. Asparagine. Kanchana. Life is daijoubu. C. Yes? I'm not so sure. I know this one is just a longer. Okay. No, I got it. It's okay. C double bond O C H2 N. Nice. And then the glutamine is HC CO minus H3N plus 2 C's and CH2 a C that splits H2N. Beautiful. That's glutamine, not glue. Glin. It's GLN. Nice. Okay. Stun Q. Oh, and the last one is YW. YC. I mean, stun Q YC. Tyrosine. Tire. This one, was it the wheel thing? This is the phenylalanine with an OH. So if I want to write it, CO minus H3N plus C benzene and an OH. Nice. Cysteine is just if you have the CO minus H3N plus H This is CH, not just OH, right? This is SH, cysteine. Good. Okay, I have to draw this one again. We have, starting from serine, our uncharged polar uncharged serine. If you ask me serine, it's CO minus H3N plus H. Serine is CH2OH. Good. Threonine, TH, T, CO minus H3N plus, that's OO minus. Threonine is C, another CH3, and but an OH here. Asparagine is ASN, CHCOO minus, H3N plus. Asparagine is CH2, a C that splits. O, H2N. Asparagine, then the Q for glutamine. Glulan, CHCOO minus, H3N plus, CH2, the C that splits into the double bond, and H2. Good job. Next, ST stun, QYC. Tyrosine, tire, Y, looks like CH and CO minus, H3N plus. This is the phenylalanine. It's like a phenylalanine, but add an OH at the end. OH. Cysteine. This is an important one. HCOO minus, H3N plus, and then welcome back, George Rojas. Dab. Yes, we are now in the amino acid structures. The scribbles are getting crazier because I'm trying to memorize them again for the nth time, but it's like osmosis, but it keeps going out and in, out and in. So the cysteine structure is, what was it? CH2 and an SH. Okay, beautiful. So far, if we want to summarize this, we have the polar, we discussed 15 out of the 20. Alright, 15 out of the 20. So non-polar is, again, hat check. Oh, thank you, hat check. I want to check. What's my hat right now? Hola. Welcome to the chat. I want to change my hat. I have the ribbon right now. I want it to be... Which one? What kind of hat will mine shapeshift? Oh, it's now a wig. No, not the wig. I'll wait for a bit before changing it. So yes, for non-polar, we have glycine, G. This is just the H. Alanine, A, just the CH3. Valine, just the V. Like that. Val, V. Oh, I want to change it now. I'll type it again. Hat. Want to change it because right now I want it to be the dab one. I want it to be the dab emote. Valine, Gab. We have leucine. What is this? I cannot understand. I apologize. There you go. Here, leucine, leucine is just, I think, this is just a longer valine. So this is the C, and then it would split. Yes, not this, don't include that part. Isoleucine is just the straight version of leucine. So it's the C. Methionine is C, met, M. Oh, I have to erase these just so they don't overlap. Yeah, methionine is met. This is what is this one? Okay, I'll just have to draw it so I can remember how it looks like. CH2, H3N. Okay, CCSC. That's methionine. And then proline. Proline is the ring. It looks like H3N plus over here. COO minus. Oh, H2, that's H2N. It will go like this 1, 2, 3, and connect to the N. What's my hat right now? Is it the dab? I don't see the dab. I will wait until I see the dab. Dab or sparkle? Hat. Hat check. Okay. That's proline, and then Gav limp FW. Phenylalanine and tryptophan. Oh, what is this? The pen that I'm using to scribble. Wow, we used it a lot. I see. Pompadour. Not the pompadour. Oh, I have the cake hat. No, it has it. Well, actually, that's fine. That's a cute hat. It's okay. I'll keep it for a bit. Phenylalanine. Phenylalanine looks like this. CH2 and just the circle. Perfect. And then the tryptophan. Oh no. Oh no. Tryptophan. This is trip. Why does it say W? Oh my goodness. I see. Tryptophan is this one. CHCOO minus. I remember. That's why. That's a good tip. CH2. And then you draw the house. You draw the bin. What is 1, 2, 3, 4, 5, 6? Why is that? No, it's supposed to be a hexagon. Then NH. 2. Or no, just NH. NH. And the bond. See, because it's a W here. Tryptophan. Nice. Right? It's just NH. Right? Just to check. Yeah, it's just NH. Non-polar is good. Now we have polar. Uncharged. What's up? Welcome to the stream, Conquer. We are discussing amino acids. By the way, you can change the hat of your character by typing exclamation hat. There's a gazillion hats possible. We have polar. Uncharged. This is stun. QYC. Serine. Sir. This is C and an OH. CH2OH. Good. Threonine. Thur. T. This is C exclamation ish. A CH3 and an OH. Perfect. Asparagine. ASN. And then this is C. Okay, I have to write the whole thing just so I remember how it looks like. CH3N plus. This one is a CH2 and then it splits. It splits. What song right now in my head? Ice Cream. The one, the one that goes Ruby-chan. I'd say, hi, it's there. It's echoing. It's echoing. Okay. And CH2 and then asparagine. No, this is glutamine. Glun. This one is CH2 and then it splits. CC. Right? It is, right? Yeah. Before it splits into double bond O and a C and an H2N. Nice. Y is tyrosine. This is a phenylalanine, a CH2 and a benzene but has an OH. Then you have the cysteine, CYSC. It looks like CH2 and then SH. Whoa! Okay. 15 I think 9 plus 6, 15. Math. So now, what are we missing? So far, wow, it's been an hour and we've just been writing these back and forth. So far we have non-polar. That's 9. We have polar, uncharged. That's 6. 9 plus 6, 15. I said we had 20. What's the missing 5? That's polar, charged. Okay. Calm down. We can do this. We can do this. The last 5 amino acids. It is... The letters look weird. Okay, so it's K, R, H, D, E. Kurde. Okay. Kurde. For K, that's lysine. Lys. How does it look like? C, H. What does it look like? How does it look like? I don't know. H. C, CO minus H2N plus. Now, this is a lot of C's. 1, 2, 3, 4, NH3 plus. Alright, good. Lysine. What's R? Arginine. Arginine. I will change my hat. It's the cake. I want it to be the dab. Arginine. Arg. A-R-G. This is... that's a weirder lysine, I see. HCCOO minus H3N plus. This one is just 3 C's. 1, 2, 3. An NH. And then you have the C that splits into NH2 plus and NH2. NH2, not you. Because this is double bonded, that's why it's positive. I need bigger space for this. So again, lysine. They have lysine and arginine. Let's take it slowly but surely. K, R, lys, arg. Lysine. This is C, H. Let's relax. We can do this. We can write it out. COO minus H3N plus. This one is HCO minus 4. 1, 2, 3, 4. And then N. Right? Okay. We have to remember that it is NH3 plus. The plus is on the N. This is H2, CH2, CH2, CH2. And then arginine. This is CCOO minus H3N. You have a scribble there. This is 1, 2, 3, an N and a C that splits into NH2 and H2 plus. You have arginine. Perfect. That's arginine. So it was KRHD. Now let's do HDE. Histidine. His. HDE. Histidine. Histidine. H. What does it look like? Oh, okay. C. H. COO minus H3N plus. This one is CH2 and a ring looking thing. Pentagon. Bond. And nope. Chill. Bond. And H plus. Bond again. And here an NH. The NH plus, that one has, though it's connected to the, but here, this electron. That's why, I mean this bond. So again, histidine, let's erase it. One more, and draw it one more time. Histidine is HCCOO minus, H3N plus, CH2, pentagon. You have a bond here and a bond here. You have NH plus and an NH over here. That's histidine. And then you have, chill out. Who is this? Oh, we didn't write it yet. Aspartic acid. Aspartic acid. This one is asp. Okay. This is CHCOO minus, H3N plus, CH2, C, double bond O, and O minus. If you remember, we have asparagine, and at the left of it, it was H2, NH2, but here it's O minus. So that's the difference between the polar uncharged and charged. Okay. Then we have aspartic acid, glutamic acid. Glutamic acid. The DE, those are acids. Fine. Glutamic acid is CHCOO minus, H3N plus, CH2, a C that splits into an O and O minus. Glutamic acid, whoop. So in theory, we should now know all 20. I'll just double check the polar charged. That is L, no, right? It was something RK. It's RK HDE. Rook HDE. Oh, Kerr HDE. Don't flip them. Kerr HDE. Lysine. How do we remember this? Lysine HCOO minus and H3 and plus. This one is, oh my gosh, what was lysine? Okay, so this one is the long one. 1, 2, 3, 4, and we have to find a way to know this. This is just CCC and 4 C's and an N and H3. Meanwhile, arginine, Arg, is CCC, N, and another C. What's up? Welcome to the stream. So far, we just have been writing the 20 amino acids. So it's alright. We're just writing. This is arginine, Arg, C, CCN, and a C. Oh no, a C that splits. Okay, fine, I will just write it properly. CH2, NH to a C that splits into NH2 plus and NH2. Okay, I have to remember this. Lysine. Histidine is, I think that one's the ring. Again, erase one more time. Lysine, R, no, not R, this is K. Lysine is K, it's positive. Lysine. Oh, I need to change my hat again. Exclamation hat. There you go. Okay, lysine is C H C O O minus H. Whoa. Don't. There you go. H3 and plus 1, 2, 3, 4, and then NH3. Yes, yes, NH3 plus. Good. His arginine K. No, R. Literally arginine. Arg. This is COO minus H3 and plus H C C C N. That's an NH, and a C that splits into NH2 plus and NH2. Great, great, great. And then the last three. You have histidine, histidine, his H. I want to see. Can we remember this? I think it has a ring. This, it's like an NH. Is it? Yeah, that's the ring. Histidine has the ring. This one here and here, because over here is NH plus and NH. Nice, nice. Now last two. Histidine. This is HDE, letter D now. D. Alright, D is aspartic acid. Aspartic acid. Asp. Maybe we can remember that with a P. It looks like it's somewhere in the D. And then glutamic acid. Acid. No. Is it? Glue? Yeah, it is. Glutamic acid. Okay. Aspartic acid. Let's calm down. Let's write it. CO minus H, H3, and plus. This one is CH. This is a C. One C? Yeah, one C. And then split. Then CHCOO minus H3N plus CH2, CH2. Oh no, what is that's a minus sign. Okay. And then a C, the one O, O minus. Perfect. And then now we try them all. From 1 to 20. Whoop. Okay. Calm down. Let's start with listing them all out, okay? We have glycine, alanine, valine, leucine, isoleucine, methionine, met, methionine, proline, P, phenylalanine, PHEF, Gablim, FW, tryptophan, terp, W. So that's 9, right? Next is uncharged polar. We have S, serine. Serine S, threonine, T, stun, N, asparagine, ASN, Q, glutamine, glun, Q, stun, QYC, tyrosine, cysteine, and then you have, this is 5, that's 9 plus 6, 15. Lastly, it is Ker, HDE. lysine, arginine, histidine, aspartic acid, and glutamic acid. Whoop whoop. 20. Now let's draw them again from the top. A mini review. Alright, let's go. Can we do it? It feels like I'm trying to fight the tower boss or something in Pal World. It's like one more time. Saya and Celine. Okay. Let's do this. So glycine. I'll just write the one letter so I get used to it. Glycine G, that is just the H. Alanine is just CH3. Valine is just your C here before you split into more C's. No, I feel like okay, I will just write it. I feel like I might add a double for valine just to be sure. CH3 COO minus H3 N plus. Yeah, here you go. CCC. Isoleucine L. You have C. That's the one that splits. Right? Not crazy, right? Yeah. Good. And then essentially that's 4. Isoleucine, I, just a straight version of leucine. Methionine is CH2. No, CC. SC. 1, 2. Yeah, CCSC, methionine. Good. Gavlimp. Proline is the weird one. Proline is, I have to draw the whole thing for this. CO minus H3N plus, no, H2 because it's proline. Then you connect 1, 2, 3. Bam. Phenylalanine is F. That one is CHCOO minus H3N plus. Phenylalanine CH2 and the ring. Nope. This is 6 sides. That's a 6-sided circle. No, that's hexagon. That's a hexagon. And then W, tryptophan. The clue is in its name. CCOO minus H3N plus HCH2. Go along here. Add a house. Add the 6 sides. This is a benzene ring. 6 sides. NH. And a line. A bond. Okay. 9 down. Next, let's go to the polar. Uncharged. Serine. C. Let's an H. CO minus H3N plus. Serine goes like this. CH2OH. Threonine is just CCOH, and then this exclamation, this H3. It's STN, asparagine, N. This is CH2, and then you split into C double bond O with an H2N plus. Does that have a plus? Or I'm gonna say it has a plus. But this is uncharged, so it doesn't have a no charge. Just to double check. Asparagine, yeah, NH2. Good. And then glutamine, CH, just longer. CH2 C double one O N H2. And then stun Q YC. We have tyrosine, which legit looks like a phenylalanine with an OH. That's it, tyrosine. And then you have who is it? Cysteine, CH2 and SH. Good. 9 plus 6, 15. Last 5. We have the arginine, RK or KR. Yeah, let's go with KR. Skart, KRHDE. This one is lysine. Lysine looks like K. Lysine. This one is a long one. CC. Right? CCC. 4 C's and then an NH3. This one is arginine. This one is CCCN. And then a C which splits into NH2 charged. That's an NH. And then NH2 with no charge. Histidine. It's here. It's okay. Ring, I think that has a ring. Histidine is CH2, 5 here and here. NH plus NH. Good. And then this is aspartic acid. Asp. This is, I'll just draw it to make sure. CH. So O minus, H3N plus. This one goes C, H something, C, and then you split C double bond O. Oh, so that's CH2. O minus. And then this one is CH2. CH2 again, and then a C that splits into O and O minus. This is glutamic acid. We did it! Yes! Oh my gosh. Okay. We did that. And take note, the DEs. No, it's okay. We just did the 20 amino acids so far. And you can also like watch it slowly while we learned it, because it was a travel. It was a journey. It was a legit journey. But I can summarize it also here. So we have 20 amino acids, right? Amino acids. And it can be broken down into the non-polar and polar. So the non-polar, that is, what was it? Oh, this is GAV-LIMP, the way I try to remember it. GAV-LIMP FW. So that is glycine, G, alanine, ALA, A, valine, VAL, V, leucine, Lu, L, isoleucine, ILE, I, methionine, met, M, proline, pro, P, phenylalanine, alanine, F, and then tryptophan with, this is terp with a W. So that's 9 so far. For the polar, we split them into two things, the no charge and the plus and minuses. So the uncharged one is S stun QYC. That's serine, Ser, S, threonine. That is Ther, T, and then you have asparagine, asin, N. You have glutamine, glyn, Q. You have tyrosine because of the Y, tyrosine with tyr Y, and then cysteine with C, cis. For the pluses and minuses, that is Ker HDE. So the first part, Ker, that's positive, that's lysine, lys K, arginine, R, see, that's why it's R, arg, and then histidine with an H, aspartic acid with an asp-T, and glutamic acid E. These are minus. So see, boom, 9 plus 6 plus 5. Okay, before I continue, let me just drink water again. Alright, so now we're gonna talk about the amino acid derivatives. Why? For fun. This is what we do for fun, okay? Aspartic acid. Amino acid derivatives. So you have, oh, where's my marker? Amino acid derivatives. You have GABA, dopamine, histamine, and thyroxine. Some of these might look familiar, some not. So GABA and dopamine, these are neurotransmitters. So GABA is a neurotransmitter that would inhibit the neural activity in the brain. Dopamine is a neurotransmitter for like pleasure, reward, or motor control. Histamine is for the allergic reactions, like your immune response. And then thyroxine, it's produced by the thyroid gland. I would have gotten a perfect score on my test if I found your channel earlier. It's okay. You found it. You're now here. The amino acids is funny. I was like, I kept on scribbling, and after we finally did the 20, it was like an hour already. I was like, what? But yeah, if you just watch that one slowly but surely, the structures will stick, hopefully. Okay, the neurotransmitters and hormones, yep, brain and hormone regulation. So, if we want to see, like, if I have a question, which of the amino acids would form an ionic bond here? You have the glutamic acid and glutamine, arginine and lysine and glutamic acid, tryptophan, tyrosine, glutamine. Let's look at them carefully. Glutamic acid and glutamine, pluses and minus, it's possible, but there is also the answer. Okay, so glutamic acid and glutamine, they're uncharged or negative. I actually, fine, I will write it. Which of these amino acids would form ionic bonds? Alright, let's go. A. It's like, imagine if this was a question on how to be a millionaire. Lamel. Okay, so there's glutamic acid and glutamine. And then you have arginine and lysine. You have lysine and glutamic acid. This is E, right? D. You have tryptophan and tyrosine. And then you have tyrosine and glutamine. What was glutamine? Q. Alright. Let's try and figure out which ones are the positively charged and negatively charged. Glutamic acid, E. Glutamine, Q. Arginine, R. Lysine, K. Alright, let's go. The positive ones Now let's start with Gav Limp FW, the no charge. I mean non-polar. Are these non-polar? Gamp Limp FW. This is non-polar. Gav Limp FW. None? Okay, that's good. And then let's go with positive no charge. No charge polar would be, let's make it blue. No charge polar is stun Q YC. No charge polar. No charge polar. No charge. Let's go with 0 for no charge polar. Stun QYC. No charge. So this one eliminates it already. No, because this is no charge polar. So no charge polar. Nope. And then you have the polar but positive. Okay, the polar positive is H. Wait, this is positive eliminated already. Come on, we know that ionic charge, it wants like a plus and a minus together, and this is a plus. And guess what, for our negative ones, that is DE. This E, bam bam, we now have our answer. Yay. Wait, look at that one. We have a plus and a minus together. So lysine and glutamic acid. Lysine has a positively charged side chain. Lysine looks like this. Oh no, that's the one I was trying to draw. KR. It's okay, calm down. COO minus, H3N plus. This is CCCCNH3 plus. Yes. Glutamic acid looks like this. CH2 CH. Yeah, right. CH2, and then you split. Just to make sure I'm not too. Yeah, it's not. You split. After you have a C, you have a double bond O, and here is an O minus. So the pluses and the minuses go together. Boom, ionic charge. Ionic bond. Okay, so the peptide bond links amino acids together to form the peptide chain. Let us draw it. Peptide bond. Wait, is my hat already the dab or not yet? I'll change it. Let me. Exclamation point. Hat. Yes. Okay. Now, going to draw the peptide bond. So, we know that an amino acid has an N terminus and a C terminus, right? C terminus, because for example, the normal structure is CH, COO minus, and H3N. Yes, R. So this is the C terminus because it has C carboxylic, and N terminus the amino in N. But if you just connect them all, you still get an N at the left or in one side and C at the one side. So let's try and draw it. If I draw H, N, H is NH3, CH, C double bond O, and an R here, CH2, CH2, S, CH2. That's the side chain. Who is this? This is methionine. This O, it disappeared though, but it's now connected to the N of another one, another amino acid, H, C. You have the R over there, and then an H, the H here, and C double bond O with something else. So if you look at it carefully, before this is C double bond O, and a CO. It's the COO something. Also, if you look at this one carefully, this is the NH3 end of one, NH, NH, and then H also here. So guess what disappeared? An O. Wait, let me switch the colors. An O oxygen and 2 hydrogens. Now guess what? An oxygen and 2 hydrogens. Huh? Water. Haha. So that's how it's formed. When you try to make them, it is, I think that's a dehydration reaction. Yeah, it is, because you dehydrate it by removing the water, and then boom, you now have what you call a peptide bond. This is a peptide bond. Peptide bond. Peptide bond. James Bond is out. Peptide bond is in. And that's how the side chains interact with one another. How many squishies are there now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sometimes it's hard to keep track of them because they move around a lot. But that's why they're cute. We keep them on screen. It's like the classroom of the elite or assassination classroom. I'm not Koro Sensei though. That is sad. Okay, next, characteristics of the peptide bond. The peptide bond, I will just try to write it properly. The peptide bond, that is, it joins together, right? It forms the backbone of the proteins. Each peptide bond connects the amino group of one to the carboxylic group of the next one. If you try to rotate them, just the phi and the psi bonds, oh no. You have different bonds. Okay. No, I don't want it. That's okay. You have a thing called the Ramachandran plot, which will, this one, Ramachandran plot, that will display the distribution of the phi and psi angles in protein structures. Alright? And you have a couple of forbidden angles in the Ramachandran plot because sometimes it's impossible due to steric hindrance. Proline is a very good candidate for the forbidden angles because you can't just flip it around. Alright, you have the phi and the psi angle. Phi angle is the rotation between your N and the alpha carbon. Meanwhile, the psi is the two C's for the two carbons. Let's try that out. Let's draw it. Okay. Here you go. If we want to draw it again, CH, COO minus, H3 and plus pH7, okay? So that's why both are ionized. And then R, you have the, I said phi angle is this, phi, PHI. Meanwhile, psi angle, psi, PSI, looks like this between the two carboxyl. Look at this T's, the carbonyl, the alpha carbon and carbonyl carbon. Yes. Phi and psi. Phi, psi. Psi, phi. No, phi and psi. Flip the psi-phi, okay? Phi and psi. Amino groups. Okay, now let's discuss the primary, secondary, and tertiary. Primary, secondary, and tertiary. Water. Okay. Water break. Alright, let's go. Primary structure. It's the sequence. Okay? So the structures, nope, not the green pen. Let's go with the black pen. There you go. Structures, protein structures. You have the primary, secondary, tertiary, quaternary. Primary is just the amino acid sequence, one dimension. Secondary is the alpha and beta helixes, the backbone. And then you have tertiary, aka just the overall 3D shape with the bonds, hydrogen bonds and all that. Quaternary is when you connect them all. Multiple polypeptide chains. And then, if you want to know the sheets, alpha helix is alpha helix and beta sheet. For alpha helix, you actually... Wait, before I move on to the beta sheet. Alpha helix looks like this. Wee. Okay, and then the distance between them is like 0.54 nanometers. And then it's like 3.6 amino acids per turn. So sheets could be anti-parallel or parallel. What do you mean by that? Okay, so for beta sheets, this is, could go like this, right? This, and then if you try to connect them, like you go like that and like that. This is anti-parallel. Meanwhile, for beta sheets, for normal parallel, you go like this. Normal parallel from here, going here, here, going here. Anyway, anti-parallel and parallel. You can see anti-parallel is like going opposite ways. Parallel is more same arrows. Okay, we have the different ways to see them. Calcium binding domains. What's the most famous quaternary? That is, I think, the hemoglobin, or at least the myoglobin. And that's for the oxygen storage in the muscles. So remember, it's important for your blood, the hemoglobin, because if you don't have enough of those, you will faint. Your body will want to get more oxygen, and so that's why it will force you to fall, and then just even out the, what's that called? Just flat ground. Okay. Fibrous proteins. Collagen is also a protein. Collagen. It looks weird, so I will not draw it. But just remember, collagen in the skin, keratin in the hair, those are all proteins. You also have some ligands. That's fine. Filaments, side chains, electrostatic. Remember the van der Waals attractions, the weak attractions that occur between the hydrophobic side chains? Yeah, good times. So remember, primary, secondary, tertiary, quaternary. 1, 2, 3, 4. 1, 2, 3, 4. No. Protein structure could also be constrained by precursor sequences. So that will just help with regulating it. Hat. Oh my gosh, thank you for reminding me. Oh wait, who has the dab hat? Oh my gosh. Cool, okay. I don't know if I'm the one who asked that, but I'll keep it there. Just in case that's my hat. Okay, protein structure determination. How? You can try stoic. You can try subunit interactions. Some strength of the problems, that's okay. Some X-ray diffraction is also possible. You can do electron density maps. And X-ray crystallography. Oh! We finished the protein structure section. Yes! Okay, that's great. I think we can actually like rest this one here for now. And then come back stronger later, okay? But thank you so much for coming by to watch the protein structure lecture. Yes, please rest and have a great day. Insert dab here. Bye bye.